So we're gonna use both of these sheets of paper today, and I'm gonna go back and forth between them, so you'll need to stick with me. Also, here's the disclaimer about this. If I zoom out to the point where you can see the whole thing, it gets too small and then people can't read it. If I zoom in, then I have to move the paper around. These are first world problems and we're going to have to just get through it. Do you get what I'm saying? But I think it's better for me to zoom in and then I'll have to move the paper a little bit. So if I move the paper and you need me to go back, all you have to do is be like, hey, Miss Cole, can you move that back? Or rewatch the video and pause it. Last thing I'm going to say before we get started is, this is always hilarious to me. I go through this step by step and explain like each part of it. And then like a week or two later, multiple people will come up to me, hey, Ms. Cole, I just came up with this really great way to remember this. And they will proceed to say exactly what I just got done saying. And I'm like, wonder where you got that from. It's funny, like they came up with it on their own. Anyway, here's our unit circle. I know, it's like I taught that lesson. I know. And then they'll be like, hey, I came up with this great way to remember it. And I'm like, okay. Exact words that came out of my mouth. The reason it's called a unit circle is because the radius is 1 unit. That is why it is called a unit circle. The radius is 1 unit. And I am going to color code, but the colors don't show up. Like that's supposed to be green. You can't see it.
What is it? All of it or just the orange?
All of it, it's green, but it just doesn't show up on the projector. Do you remember how last time up there it said trig with any angle?
Yep.
Today we're going to do only very specific angles that are on this circle, which is actually better because it makes your world smaller. All right, the only choices that there are. Now we've actually done a good bit of this already. I'm going to start, if you want to use your first color, if you want to color code with me, mine's green. You can pick whatever color you want. We have already done the up, down, left, right ones. Now this center point is the origin. That's 0, 0. And what I'm going to have us do is go around and do the up, down, left, right ones. So we're going to start over here. If you have not rotated anywhere at all, you have gone 0 degrees and you have gone 0 pi radians. Technically, you don't need the pi, but I'm going to recommend you put it, and you're going to see why in just a minute, because we're also going to put the coordinate points on there. So if this is the origin and your radius is 1 unit, you went 1 unit this direction. What is that coordinate point right there? It's 1, 0. And I like for you to put the pi with the 0 pi radians so you don't mix it up with that 0. Do you get what I'm saying? Because that's 0 pi, no pi. This is part of a point 1, 0. All right, let's go up to the top. How many degrees was that?
20.
90. There we go. You were really confident though, so I feel bad. Hold on to that answer. That'll be the next one. All right, what was that in radians? Do you remember that one? Half of a pi, pi over 2. And now look, if this is the origin and the radius of the circle is 1 unit, what is that coordinate point? You went up 1, 0, 1. Good. All right, now we're over here. How many degrees did we rotate? 180. Good. And how many radians is that? 1 pi. Good. And if this is the origin and the radius of the circle is 1, you went to the left 1 now. So what is that coordinate point? Yeah, -1, 0. And then if we rotate all the way around to here, it's 270. Now, if you count with your pi's, this is a half a pi. That's 2 halves pi. So this is 3 halves pi. Do not write 1.5 pi or 1.5 pi. That's not a thing. I will mark that wrong. Oh, it's the same number. No, we don't write that. It's not a thing, right? And then if this is the origin and you went down 1 unit, what's the coordinate point? Yeah, good. We're on our way. Look, we did all of that already and you already knew it. So what we're going to do is go back to the piece of paper I gave you. I'm going to show you like one thing and we'll come back to the circle. We'll show you the next thing. We'll come back to the circle. So where these special angles come from, because remember, it's not any old angle. We're going to do very special ones. Where they come from are your special right triangles. So what I want you to do is go ahead and draw a triangle. We're just going to draw in quadrant 1. It's not to scale, just put a triangle. For all of the triangles, the hypotenuse is now 1. R is 1 because it is a unit circle. Do you get what I'm saying? They're all 1. It's not any old angle now. They're very special ones, all right? For 45, 45, 90, if you don't remember this, that's okay. We did it a while ago. To get from the hypotenuse to one of the sides, you divide by square root of 2. Does that ring any bells as sort of familiar? Like, do you remember dividing by square root of 2? I did sit up here and teach it to you. It happened, all right? If you rationalize that, what are you gonna get?
Oh, 1 square root of 2 over 2.
Perfect. So this is square root of 2 over 2, and this is square root of 2 over 2. Because it's 45, 45, 90. Those are both the same. We're on board? All right. We're going to go back to the circle. If you want to get your second color out, mine's going to be purple. If you want to make it match, you're not going to be able to see it. Huh? And we're going to go and do all the ones that match with this. Okay. So we're going to go around and do all the degrees first. So if you start with 0, and this is going to be the one in the middle, we're going to do all the center ones. All right. So this would be 45. Can you tell that that's at least different than the green? No, it looks all the same. And we're just going to keep on adding 45. So if you add 45 to 45, you get 90. That's that one. It's already on there. If you do 90 plus 45, 135. Good. If you add 45 to that, you get 180, which is already on there. If you add 45 to that, you get 225. If you add 45 to that, it's 270. That one's already on there. If you add 45 to that, good job, guys. And then if you add 45 to that, you should get 360, which is the whole way around. You see what we did there? So do you have to memorize it? No. If you can add, then you're good. Okay. Now watch, with the radians, it's even easier. For 45 degrees, it's pi over 4. I've taught you how to convert. If you don't believe me, you can go back and check that, all right? We are just going to count by fourths. Are you ready? This is why radians are easier. That is 1/4. This is 2/4. Do you see that? So this one is 3/4. 1 whole pi is 4/4. So the next one is 5/4. Yeah. This was 2/4 right here. So this one's 3/4. 1 whole pi is 4/4. This one's 5/4. 6/4 is this one. So 7/4. Let me make sure I put it on the right line. And then 8/4 is 2 whole pi, which is the whole way around. So do you have to memorize it? No, if you can count to 8, you're good, okay? Where did I lose you? So remember this triangle that we did here? How it was square root of 2 over 2? Square root of 2 over 2? Look at, that means this coordinate point is square root of 2 over 2, comma, square root of 2 over 2. It comes from your 45, 45, 90 triangle. I'm going to wait till you're done writing that so everyone can watch me point at this so I don't lose you again. Watch me point to it. I'm going to take that point and reflect it over here. And the only thing that's going to change is that since we went to the left, it is negative square root of 2 over 2, comma, square root of 2 over 2. And then if I reflect that one down to here, what's the only thing that's going to change? They're both negative. And then if I reflect that over to here, what's the only thing that's going to change? Good. So square root of 2 over 2, negative square root of 2 over 2. So do you have to memorize it? No, you just take the first one and reflect it over and put your negatives in the right spot. That's all that it is. It is not memorization. The amount of information you need to know is very, very tiny. You just keep doing the same thing over and over again. Okay, cool? All right, we're going to go back to our piece of paper and I'll show you the last one and we'll finish filling it in. So 30, 60, 90. I'm gonna try and draw these like sort of to scale. Here, this one was the 45. I guess I should put my 45 in there. So I'll put 60 in this one, and then if you draw it like the other way, it would be the 30. I tried to make that sort of to scale. It doesn't really matter though. But again, for all of these, what is R? Because it's a unit circle. 1, the hypotenuse or R is 1 for all of them. If you didn't remember the 45, 45, 90 pattern, you're probably not going to remember this one, but I did sit up here and teach it to you. There's a video on Schoology if you want to rewatch it. To get from the hypotenuse to the smaller side, you divide by 2. So 1 divided by 2 is a half. And to get from the smaller side to the bigger side, you multiply by square root of 3. So a half times square root of 3 is 1/2 square root of 3, or we usually just say square root of 3 over 2. I've never seen anyone put the 1 in there. But what's the only difference that's going to happen with this one? Since I just drew the triangle the other way, it's reversed. You have square root of 3 over 2 and 1/2 there. So it's just the other way around. Do you need a ruler? It doesn't need to look perfect. Like I said, I attempted to make it a little bit to scale there. I tried to make the 60 bigger than the 30, but it doesn't really matter. Are you guys all right? Oh, look at you knowing that I put those back there. Nice job. I was going to bring that up. But... All right, so let's go over to the circle. I'm going to take a different color. This one's going to be blue. I left that up there forever. You're still not done.
I was drawing my line.
Oh, geez. We ain't going to finish this.
Okay, sorry.
Okay, so actually, you know what? I'm gonna use both colors for these. I'm gonna try and make the 30s the blue and the 60s the red, but I'll see. I have to keep switching back and forth, okay? Yes, but I need to finish this before I can hit go on it, all right? So this first one's 30, and we're just gonna keep adding 30. Are you ready? So 30 plus 30, 60. So I made that one blue. This one's gonna be red, but you can't really tell. Or can you sort of? Oh, you can sort of tell with the red. And then just keep adding 30. Look at you. You have to stop talking over me. 60 plus 30 is 90. That's already on there. 90 plus 30 is 120. Add 30 again. 150. Good. I'm trying to make that one blue. I'm trying to make the ones across from each other the same color so that you can see them reflecting. Yeah. So the ones across. So I made these 2 red and I made these 2 blue. I'm trying to make the ones that reflect the same color. All right. 150 plus 30 is 180. That one's already on there. Add 30 again. 210. Very good. That reflects with this one. So I made that one blue. I really wish it would show up. All right, add 30 again. That's 240. And do you see how I switched colors? I want that. See, I can't have the whole circle up here at once or it makes it too small. So that reflected 240. 240 plus 30, 270. So that one's already on there. Add 30 again, 300. Add 30 again, 330. Add 30 again, 360, and that's the whole way around. So do you memorize it? No. If you can add 30, that's all you're doing. 30, 30, 30, 30, 30, the whole way around. All right, now we're going to do the radians. We're going to count by 6. It's pi over 6. If you don't believe me, you can convert it. It's what 30 converts to. All right. It always sounds like I'm lisping when I do this one. That's 1/6. So the next one is 2/6, but that reduces. 2/6, it's 1/3. Good. So 1/6, 2/6, 3/6, 3/6. Guys, what does that reduce to? A half. Do you see how that's right there? Okay. The next one would be 4/6. What does that reduce to? 2/3. Good. This is really just reducing fractions. The next one is, that was 4, 6, so the next one is 5, 6, good. And then 6, 6 is one whole pot. What's the next one? 7, 6, good. See, you can count, you can do it. You are just counting. It is not memorization. 7, 6, this one would be 8, 6. That would reduce to 4/3. That's 8, 6. 9, 6 reduces to 3/2. So that's 9, 6. 10, 6 reduces to 5/3. That's 10, 6. And then 11, 6. And then guess what 12, 6 is? 2 pi, which is the whole way around. Did I tell you to memorize anything? No, I said count 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6, the whole way around. You just have to reduce fractions. All right. Now we're going to put in the sides of our triangles. Do you see how it was 1/2 and square root of 3/2? Here's how I remember which one goes where. Can you watch me point to this? Do you see how if you're at this point, do you see how the x distance is bigger than the y distance? Okay, so the x has to be the square root of 3/2 and the y has to be the 1/2. 3 is bigger than 1. The x distance was bigger than the y distance if you were to draw in that triangle. So then when I go to this one, do you see how if I drew in this triangle, it would be reversed? It's the other way around. And now I'm just going to take them and reflect them. Watch me point to this. If I take this and reflect it over to here, what's the only thing that's going to change? Which one gets the negative? Perfect. And if I take this one and reflect it over here, same thing. It'll be negative square root of 3/2, 1/2. Then I'm going to take them and reflect them both down to the third quadrant. They're both negative. All right. So this one is negative square root of 3/2, negative 1/2. This one is negative 1/2, negative square root of 3/2. So you only really need to remember, or if you want to call it memorize, you only really need to memorize quadrant 1. Because after that, you just reflect it to all the other quadrants. All right. Then I'm going to take them and reflect them into quadrant 4. What gets the negative in quadrant 4?
1. Oh, wait, no.
The x or the y, I guess we'll say it that way. What gets the negative in quadrant 4? The y value. Good. So this one would be 1/2 negative square root of 3/2. And then this one would be square root of 3/2, negative 1/2. Now, if you want to, you do not have to do this. If you want to use like the edge of your paper or something, or if you want to borrow this ruler, you can. And again, it doesn't really show up great on here, but you can connect these points so you can see the reflection happening if you want to. And it looks kind of cool once you connect them all. Humor me for a second. It does look neat when you connect them. Get the red one. Yeah, it looks sort of trippy. It looks kind of like a vortex once you connect them all. I don't like to write through my numbers there. Do you guys see what I'm doing here though? Like what I'm trying to illustrate for you? Like how it's reflecting. What was my other color? Purple? It's like art in math class here. There, you see that? You see that? So go back to your piece of paper. I'm going to do one more thing and then I'll give you another really fast break. So what you need to remember are what go across from each other. And all you have is a small angle, a medium angle, and a large angle. The small one is 30. The medium one is 45. The large one is 60. In radians, that would be pi over 6, pi over 4, and pi over 3. The way I remember that is, if you got offered a 1/6 of a pi, you would be like, hey, that's not very much pi, right? A 1/6, that's a small slice. A 1/4 of a pie, that's bigger. And if you probably shouldn't eat a 1/3 of a pie, that would not be a good idea. Do you get what I'm saying? Small, medium, big. Okay. It depends on how large the pie was. That depends on the radius of the pie. Okay. Across from the small angle. Do you remember how the small side goes across from the small angle? Remember this? Okay. The small side is the 1/2. The medium side is the square root of 2 over 2. And the large side is the square root of 3 over 2. Do you see 1, 2, 3? 1, 2, 3. Small, medium, large. You just need to remember small goes with small, medium goes with medium, and large goes with large. Are you gentlemen okay back there? All right, so what we're going to do is take what we just did and apply it to doing our trig. This is exactly what you did last time, except only for these specific angles. Remember how last time it was any old angle? It could be anywhere. Now it's specifically for these. So your world is a whole lot smaller. I would still like to illustrate it for you. Go ahead and draw a triangle. This is X, this is Y. Do you remember how last class we wrote R? Guys, enough. You're distracting me. I'm leading the party, so if you're distracting me, that's not good. Do you remember how last time we wrote R? What is R for all of them now? 1. It is a unit circle. The radius is 1, so that will all be 1. So when you go to do sine, sine is opposite over hypotenuse. Watch me point to this. That would be Y over 1, which is just Y. Good. Sine is the Y value. Cosine is adjacent over hypotenuse, so that would be good. It'd be X over 1, which is just X. And then tangent is Y over X. Now, when you flip cotangent, that usually goes okay. Everybody's fine with that. These are the two that get messed up. You know what? Actually, I just made a split decision. I'm not going to write it like I have in years past because that messes everybody up. When I write 1 over Y, everyone loses their mind and it gets super confusing. So here's what I'm going to do instead. I'm going to write it this way. Flip the Y value. And for this one, you're going to flip the X value. You are just reciprocating. That's all that it is. Because what happens is people will write 1 over square root of 3 over 2, and then they get super confused. And I'm like, what are you doing? All you do is flip it over. You know what a reciprocal is, right? Just flip it. I've never taught it like that before. We'll see if it goes better this year. All right, I'm going to just do the odd ones. I'll write up the others. Here are your steps though. If you're a steps person here, if you're a steps person, I'll give you steps. Step number 1, you decide what quadrant you're in. And there are only 4. So if you get stuck, pick one. Okay. Then you're going to decide what your angle is. And here's the good news. It is either, if it's in degrees, 30, 45, or 60, or if it's in radians, pi over 6, pi over 4, pi over 3. Those are the only choices. So if you get stuck, pick one. You have very few options, right? Then you're going to label the sides, which are either 1/2 square root of 2 over 2 or square root of 3 over 2. Those are the only choices. Do you get what I'm saying? How you have almost no choices for your answers, right? And then lastly, you're going to say the answer, which comes from this right here, whether it's sine, cosine, tangent, or what have you, right? So 210, step 1, what quadrant is 210 in? 3, draw a triangle in quadrant 3. And I always get somebody that's like, do I have to? I will give you no credit if you don't draw and label a triangle. I am not messing around. This is your work. This is the quote unquote work, is drawing a triangle, right? What is your reference angle? Now for degrees, it is either 30, 45, or 60. So what do you think is your reference angle in here?
30.
Why is it 30? Because that's correct. Awesome. Well, why wouldn't it be the 60 though? Because what is to here worth? 180, but we went to 210, so, okay. What goes across from the 30? Well, the 30 is the little angle. Across from the 30, do you see how across from 30 is 1/2? Across from the small side or across from the small angle is the small side. Now look, if that's 1/2, that means your other side has to be square root of 3/2. Those are the ones that go together because it's a 30, 60, 90. Now, does anything get a negative? If you're not in quadrant 1, you have to watch your negative. Good. Why both? All right, that is your work. That is the amount of work that I need to see. Now you just answer the question. It says sine. Look it. Sine is y. Which one of the numbers on that triangle is the y value? -1/2 is your answer. This is the work. That's the answer. We're going to just do the odd ones. I think I have the rest of them as radians, and radians are easier, in my opinion. All right, yeah, the rest of these are radians. All right. What quadrant is 5/6 in? Good. Oh my gosh, you guys are nailing that like right off the bat. This is why these are easier. The reference angle, the denominator just matches. So do you see how that's 6? Your reference angle is pi/6. It's just going to match. Now, if I offer you 1/6 of a pie, do you get how that's a small slice? The little one, across from the little one is 1/2. That's the little side. They go 1, 2, 3. Now, if that's 1/2, what does that mean the other side is? Oh my gosh, perfect. We're getting it. We're getting it. Perfect. All right. Now, we're not in quadrant 1, so watch your negative. Something is going to be negative. Yeah, good. Perfect. Oh my gosh, we got it. That's your work. You did the work. Good job. Now we're just going to do the answer. Tangent is y/x, or if you still want to think of that as opposite over adjacent, that's fine. It's going to be 1/2 over -square root of 3/2. And before you panic, just trust the process, okay? What cancels out in that? The 2's. So you have -1 over square root of 3, and then you have to rationalize that. So it will be negative what? Yeah. Don't hurt yourself. I know what you mean. And I'm sorry, what was your question? Oh, okay. So we put y/x, the 2's canceled. We ended up with 1 over -square root of 3, and then we rationalized, right? Again, I'm going to just do the odd ones for this. Where is, in what quadrant, 7, 6? 3, good. What's the reference angle? Don't overthink that. It just matches, guys.
I'm going negative square root,
Well,
square root of 3/2.
Hold on a second. First of all, that's not an angle. Secondly, reference angles can't be negative.
Oh.
But it's pi/6.
I wasn't thinking of the side.
So 30's not like wrong. I will mark it wrong though, because if it's in radians, you have to stay in radians. All right. So pi/6. That's the small one. What goes across from that?
1/2.
Good. That means the other side
That's the opposite.
touches ahead of him. But see, do you see what I'm saying? If you're like, it feels like we're doing the same thing over and over again, Miss Cole. Yep. And this is like the rest. Once you get the hang of this,
They
it's,
both have to be negative.
oh, good. They're both negative. And then you answer the question. Secant is the reciprocal of cosine. Cosine is x. Which one of these is x? Good, that's this one. You're just going to flip it over. And then you rationalize that. So it will be negative what? Beautiful. All right, let's do the number 7. Actually, I might go back and do one that has a 4th in it because we didn't have one that has a 4th in it. All right, where is 2/3? Second, good. What's your reference angle? And don't overthink this. It just needs to match. Bless you. Yeah, pi/3. You see how that's a 3? It's just going to match. Now, if I offer you 1/3 of a pi, that's a lot of pi. That's the biggest side. So what goes across from pi/3? And some people, instead of small, medium, large, will just remember the ones with the 3's go across from each other. That's another way you can remember it. But what does that mean this side is? 1/2. -1/2. Good. That's your work. All right. And then you answer the question. This one says sine. Sine is the y value. Which one of those is y? That's your answer. Let me go back and grab one that had a pi/4, and then we'll do one of these last ones. So we're going to go back and do number 4. This one's negative, so be careful. If you rotate negatively, what quadrant is that in? Fourths, good. And hold on one second, your angle, your reference angle is pi over 4 because it can't be negative. Go ahead.
How do you know where to put like the square root of the two and those?
So the small side goes across from the small angle, the medium side goes across from the medium angle, and the large side goes across from the large angle. So it depends on what your angle is, which one goes across from that. Okay? So what goes across from the pi over 4? The medium one, which is square root of 2 over 2. Good. What does that mean the other side is?
Wait,
wait, square root of 2 over 2.
It's square root of 2 over 2, guys. That's the 45, 45, 90. So those are the same. Now it's not quadrant 1, so something's negative. Which one of those is the negative? The y one. Good. You guys are good on those negatives. All right, now hold on. It says cosecant. Cosecant is the reciprocal of sine. It means you're going to flip the y value. This one's the y value. You have to reciprocate that.
you gotta fix it.
You have to fix it. Good. So it will be negative 2 square root of 2 over 2. It's like a million 2's here. And then those 2's cancel. It's just negative square root of 2. And then let me do either 9, 10, 11, or 12. Let's do 9 because I said I was going to do the odd ones here. These ones are your quadrant angles, the up, down, left, right, or sometimes I call them the compass points. You won't get a triangle for these. Instead, you will get a circle because it lands on the axes. So you don't get a triangle. They're actually easier, but just, stick with me here.
How many numbers?
Because it ends with, it is over a 2. It's not over a 3, 4, or 6. So they're your like compass point ones. Using a word like up, down, left, or right, where is 3 pi over 2? Up, down, left, or right?
Down.
Down. It is right here. Well, just down. What is that coordinate point? Good. Here, we'll have to do another one of these. That is the quote unquote work if it's one of your compass point ones. Okay. Then you answer the question. It says sine. Sine is the y value. Which one of those is the y value? Negative 1. Let's do 10. Draw your circle using a word like up, down, left, or right. Where is pi? 1 whole pi. To the left. Good. What is that coordinate point? There, we got there. Okay, we just needed to do another one. That's the quote unquote work. So those are actually easier. There's less work to draw a circle. All right. Tangent is y over x. That is 0 over negative 1. Now here's where we have that crisis. Is that 0 or is that undefined?
So that's. Yeah.
When would you get an undefined? You divide by 0, which does happen. Okay, so if you get a division by 0, that's undefined. Okay,